Okay, so this is a video going over polyatomic ion rules. So we have polyatomic ions, which, just a refresher in case you're watching this because you missed class or whatever may be the case. A polyatomic ion is a group of atoms that are bonded together, and then they have an overall charge. And so they're going to interact with things ionically. And so we use them in ionic compounds when we're naming. We learned how to draw polyatomic ions. Now we're going to learn the names. So there's 13 really common polyatomic ions, which normally I make y'all memorize those names. And then from there you can apply these rules, and it lets you be able to name tons more. But that being said, you obviously don't have to memorize them this year because it's hard to memorize things with COVID. But I encourage you to, especially if you're interested in AP, to memorize the polyatomic ions. It's just going to make your life easier. And that being said, we have to learn the rules. And so whenever we learn the rules, we can name more. And you will see the rules applied frequently. So you do need to learn the rules. You don't have to memorize the rules. I don't even make my pre-AP students on a normal year memorize the rules. But you do need to know how to apply the rules. So we're going to go through the rules. There's only 5 total rules. And we're going to apply each of them. And so hopefully they make sense. So the first rule, and it's listed on your polyatomic ion sheet, if you go towards the bottom, says rules for other related polyatomic ions. And it says rule number 1, bi or hydrogen means add a hydrogen. And then you're also going to add a +1 to the charge. Because when we add a hydrogen has a +1 charge, so it takes one away essentially. So we're going to apply it to 2 different compounds. So we have phosphate right here. So here's the name, phosphate, and then here's the formula. So if I add a hydrogen to the formula, I also add bi to the name, or if I add bi to the formula, I add. So we're going to do that. So I'm going to put it in pink so you can see. So if I do this bi, and then it would be still phosphate. So we're just adding it to the name. So I just added it to the name, biphosphate. And then that means that the formula, I'm going to add a hydrogen. So I add a hydrogen. It is still PO4, but then we change the charge because that hydrogen had a +1 charge. So it makes our charge now, instead of -3, it makes it -2. And so that is how you apply that. The other way that we could do that is, instead of saying bi, we could also use the word hydrogen right here. So we could have said biphosphate or hydrogen phosphate. It means the same thing. So I'm going to apply it to another one. So now we have sulfate, SO4 -2. So I'm going to add my hydrogen. And this time I'm not going to do it in pink so you can kind of see what it would just look like. So if I add my hydrogen to the formula, so it's still H. So I added the H, but it's still SO4. I still have the same number of oxygens, same number of sulfurs. Now then the charge changes by a +1. So instead of -2, it's now -1. The name needs to change, so I need to add hydrogen or bi to the name. I personally like bi just because it's faster and easier, but hydrogen works too. And so this becomes bisulfate. So it becomes bisulfate. So the bi in front tells me I added a hydrogen and I changed the charge. So that's how you apply rule number 1. Okay, rule number 2 says dihydrogen means add 2 hydrogens. And if I add 2 hydrogens, then that's a +2 charge. Because if 1 hydrogen was a +1 charge, 2 hydrogens is a +2 charge. So we'll apply this rule. This rule only really applies to phosphate. Why? Because these are polyatomic ions. And so an ion has to have a charge. If it doesn't have a charge, it's a compound, and we've learned how to name compounds at this point. So, for right here, why it won't work with sulfate is if I add 2 hydrogens, so I do H2SO4, and then I add a +2 to the charge, so my charge is 0. And this isn't dihydrogen phosphate. This would be an acid, which we'll learn how to name acids later, but this is an actual compound because it doesn't have a charge. So you can't do it to things with just a plus or a -2 or a -1 charge. The only ones you can do it to is a -3 charge, and the only polyatomic ion that we know that has a -3 charge is phosphate. So phosphate, when we do this, if we add 2 of them, so it'd be H So it becomes H2PO4 minus 1. Why? Because I'm going back to the original, which is minus 3, and I added 2 hydrogens. So that means I needed to add a plus 2 charge. So then minus 3 plus 2 is just minus 1. And it becomes dihydrogen phosphate. Okay? Dihydrogen phosphate. Di means 2, so we added 2 hydrogens to phosphate. So that's how you apply rules 1 and 2. Already done with those. Okay, so we're going to shift gears and come over here to rules 3, 4, and 5. Okay, so rule 3 says per means add an oxygen to the 8 form. So this is chlor 8, so this is my 8 form. I have 8, which is my ending, chlor, which is my stem. So this is my ending. Okay, so then if I add an oxygen to the 8 form, I add per at the beginning. And so I'm going to add an oxygen. So now this becomes ClO4 minus 1. And there is no charge change here. And it tells you that in parentheses. And so now I add per, a prefix. I keep my same stem, but now I have per and then chlor 8. So my ending doesn't change. My stem doesn't change. I just added a prefix, which is per. So I have per chlor 8. So that is rule number 3. If you add per to the beginning, you're adding an oxygen to the 8 form, specifically the 8 form. Okay, rule number 4 says ite means 1 less oxygen than the 8 form. No charge change. So I have my 8 form. So now I'm going to do 1 less oxygen than the 8 form, which would be a 2, no charge change. And so now I'm going to change my ending. My stem stays the same because my stem is telling me it's a mixture of chlorine and oxygen. And then the ending and the prefix tell me how many oxygens I need. And so chlorite, I have a new ending, but I have the same stem. Okay? And then I have, the last one says hypo means 1 less oxygen than the ite form. So now I have the ite form, so I want 1 less oxygen than that. And so then if I have hypo chlorite, that would be 1 less oxygen, which would just be ClO. Since there's just 1, I don't have to put an actual subscript of 1. So I'm going to erase these so that way it is less confusing. You can just kind of see what it looks like. Okay, so we have 1 more oxygen than the 8 form is per 8. This is my 8 form, which is most of what it's listed out as. 1 less oxygen than the 8 form would be ite. 2 less oxygens than the 8 form would be hypoite, or you could think about it as 1 less oxygen than your ite form. Okay, and so this is how it goes every single time. And so we could do another one. This is one of the few that actually has the per, 8, ite, and hypoite in the real world. But this is kind of an intro to the rules so you can kind of understand how to apply them.